I will start by some kind of context about the topic of the talk, which is about the color and the atmosphere, which I will define as an interaction between the atmosphere as an object and the light. And then I will present 3 recent works that are related to this topic. And since we are in Antwerp, it's the city of painting, so I thought it's interesting to focus the beginning of the talk on the topic of painting. And so I was searching for, actually Haseeb came up with the title of the talk. We were talking over the phone. And so after this title, color and atmosphere, came up, I started to think, okay, how can I contextualize this question in terms of art and science, because my work is really about both fields. And so I searched a bit in the history of art. So there is this painting by Rubens, which I always found strange because the colors of the rainbow are completely wrong. And so I looked also a bit on Turner, because he obviously worked a lot about the atmosphere and the colors of the atmosphere. I checked a bit the Impressionists. Olafur Eliasson also has some works there. But finally, the most interesting thing I found out was about Leonardo da Vinci. So I'm going to talk about Leonardo da Vinci a little bit. But first, I read the text of Haseeb, and I found that small part of what he wrote about the relatively thin atmosphere that sustains all life. And so I asked myself, yeah, right, how thin is that thing? So I checked. Actually, I forgot that this is just the Wikipedia information. And so I saw that, okay, 50% of the mass of the atmosphere is below 5.6 kilometers, and 90% of the whole thing is below 16. And after that, there's like 10% left on almost 85 kilometers. So I took Photoshop, I made a circle, and I tried to represent that. So how thin is that? So here you have the 100%, which is the blue thing. But if I remove only 10% of it, that's becoming pretty thin. And so when I zoom, it's still very thin. Right? And so indeed, it's very thin, the Earth's atmosphere. But it appears blue when it's hit by sunlight. It appears blue when it's seen from outside. Here on the picture, you see the shadow of the moon. This is an eclipse that we see on the picture. And you see that that's also called the night. You know, when the sun stops hitting the Earth, this light blue color that emanates from the planet just vanishes. And so the atmosphere is also blue when it's seen from the inside, when we are on the planet, and you look at the sky during the day, and the sky is, well, in Belgium often it's gray, but it's often blue. So it's blue from the inside and it's blue from the outside. This picture is a detail from a painting from Da Vinci workshop. And so yesterday I was preparing this talk, and I thought, okay, I'm going to check how Da Vinci thought of atmosphere and the color of the atmosphere, because I had the feeling that probably there's some very interesting things there. And so I checked some part of his notebooks that I could find online, and I found that, okay, I mean, it may seem obvious, but because we have the day and we have the night, and during the night the sky is all black, but it's still not completely evident that in the 15th century, somebody would say, of course, we live on a planet which is surrounded by darkness. Maybe, I mean, it may seem obvious or maybe not, I don't know. Some people thought the Earth is flat, so why should it be surrounded by darkness? You know? And so I found that Da Vinci knew that, and he was saying that the blueness of the atmosphere is not a color intrinsic to the atmosphere, but it's caused by vapor and atoms on which the solar rays are falling. And these rays are rendering the atmosphere luminous against the darkness which is behind and which includes the atmosphere and the planets. And I thought this is quite amazing because we would describe this situation exactly in the same way today. And actually, one thing which was even more interesting is that he designed a kind of scientific experiment to prove it. And for this scientific experiment, he used simply painting pigments. So he's saying that if you want a proof of where this blue is coming from, and also, which is also proof of that the atmosphere has actually no color, you will paint a board with a very black painting, and on the top of it, you will put a very thin layer of white paint. And if you do that, well, this white paint will become bluish, and nowhere will be more blue than on top of a black paint. But for this, the pigment, the white paint, must be made of pigment that are very, very finely ground. And I was really amazed to read that, because I've been working on this, and but it's always the same when you work on something, you read Da Vinci and he already figured it out. So. And so his description of the atmosphere is very similar to the one we would use today. This is a very simplified picture, but it shows you basically why the sky is blue. So you have the sun in the darkness outside, and the sun emits light on the earth, and this light is made of, if you want, it's a simplification, but it's made of rays of different colors. And some rays have a tendency to interact with the atmosphere by being deviated much more than the others. And so those are the blue rays. So the blue light from the sun has a tendency not to go straight in the atmosphere, but to be diffused, so to go all over the place. And this is why the sky is blue. We call, in fact, the Earth's atmosphere a diffusor, and the light is scattered by the atmosphere. And it's interesting because somehow what Da Vinci made is quite a huge jump from like the kilometer scale of the atmosphere to the sub-millimeter scale of a paint coating. He said that these two things that are completely different in dimensions are actually the same thing. And I found this very interesting, also related to what Olivier said, because this is really well, Da Vinci was a scientist, and he thinks, he conceptualizes painting as a science, and what he does is using natural phenomena to actually create paintings. And there is a kind of interesting thing there happening that I think is, I mean, I would like to, it's better if we develop this in the discussion after, sorry. Another object that is behaving in the same way is called opalescent glass. So this is a piece of glass. It appears blue, but you see that it's blue, but the color that is transmitted, that goes through the glass, becomes yellow, orange, or a bit reddish. And so it's exactly like a small atmosphere in miniature. The light arrives on the glass, the blue part of the light is diffused, and it makes the glass, which is colorless, appear blue. And the rest of the light, which is the white light minus the blue part that has colored the glass in blue, became yellow. And so I think it's interesting that you know, you have the same phenomenon on the a gigantic thing which seen from far is very thin and very small objects. So the same colors appear in the opalescent glass and in the sky, and the cause is the same. And I think the key concept around this is that the colors of the atmosphere are actually produced by materials and objects that don't have a color. So the light from the sun arriving on Earth is white, and the atmosphere has no color. But by the transformation of the structure or of the trajectory of the light inside of the object, the colors are appearing. And I think this is a very important way to describe or to understand maybe how the colors of the atmosphere are working. And so this is a small video I made yesterday. This is a piece of opalescent glass, and it also behaves a little bit like a small Earth atmosphere. When I put it close to my white LEDs, it's becoming white bluish, but when I look at the white LEDs through the glass, they become very yellow. And this is because it's not really exactly like a filter, it's more that the light from the LEDs is turning the whole glass blue, and so there's a part of the light which is missing, and so the light that passes through the glass in straight line and goes right to our eyes becomes yellow because the blue part has colored the glass in blue. So this is a opalescent glass. It's also a piece of glass from a factory that makes glass for the churches, for the stained glass. I will show you the picture after. But basically I wanted to introduce the talk by that idea of that studying, conceptualizing, reproducing, I think this word is interesting, and reappropriating natural phenomena with a scientific method. It's actually a good introduction to my artistic practice. So I'm going to first present, my presentations will be quick because we don't have much time, but I'm going to present 3 projects, and this one is, it's a project where I conceived in the frame of a competition. I conceived 24 stained glass windows for a church in France. It was a competition, and it was a Cistercian church. And the Cistercians in the Middle Ages had a rule for their art. Color was not allowed, only colorless materials. And also representation, even symbolical representation, were forbidden, at least at the beginning of the Cistercian dogma, because very quickly it faded. And so in reference to this art from the Middle Ages, I designed an algorithm that generated geometrical patterns that could be produced with like a traditional stained glass technique. And I studied the property of the glass, and in particular of the opalescent glass, in order to create visual effects by the interaction of the natural light and of the glass. So these are some pictures of a book that I published later with some explanations about how I work by combining mathematics, geometry, etc. And how this generates patterns that then became stained glass. And so my idea for the project was to create colorless windows by using different type of glass, transparent and opalescent. And the opalescent glass is much brighter when it's illuminated by sunlight. And so I created a composition in 4 movements, because there are 4 facades in the church. You will see the pictures after. And the sun was kind of the conductor of the orchestra for the whole project. Well, I tell you immediately, the project was never realized because we lost in the final, but we could make one prototype and show that our idea was kind of working. So these are some pictures of the application that I made. It's kind of a gigantic clock around the church. The line there represents the course of the sun with the color of the sunlight. And there are 4 movements that are representing the cycle of one day, but also the cycle of one life, because the church it's a very symbolic place where people are born, or where people die, or they're buried, etc. So I went there, I measured the light around the church, the color of the sky, the color of the sunlight, and this is a piece of opalescent glass under the sun. You can see that it becomes very bright against the background, if the background is in the shadow. So this is an illustration of the work that has been done, the study. So you have 2 lines with spectrum of the light coming from the sky, spectrum from the light coming from the sun. And these 2 things are like the background of the score, of the kind of musical score that has been created later on. And then I also created these algorithms that generate geometrical patterns that later became like this kind of complex map to create an actual piece of stained glass with the lead lines and the different types of glass. These are other pictures from the algorithm. And yeah, I worked with a traditional glass factory in Germany where they have they have more than 5,000 different types of glass. And I just wanted to show you because it's wonderful. So that was the CEO of the company at the time, the funny guy. And this is how they make glass. So they have this huge workshop and they make glass, they blow glass bottles, like very big bottles, that they turn into cylinders. And then the cylinders are cut, then they pass by another oven where the cylinders are becoming flat again on a stone table at relatively low temperature. And so in my project, the idea was that every window would have two different moments. One moment where it's in the shadow, and one moment where when it is under the sun. So under the sun it becomes colorless but very bright, and under the shadow some colors appear and all the contrast disappears. And so this is what was happening to, for example, one window during the course of the day. So here you have the color and the presence or the absence of sunlight, and on the top line you have the color of the sky, which is behind the window. And these are the two parameters that influence the visual aspect of the window. And so you can see that the same window passes by two main stages, but with also a lot of changes in color. And so these are pictures of the real window that we produced. I was kind of proud of myself because these were my simulations and this was what we built, so it was quite correct. These are other pictures of the same object, but on a light table. So you can see that the opal glass appear completely colorless, and the other are transparent and they have some strong colors. But these strong colors in situ, under the sunlight, almost completely vanish, but they are translated on the stone. So the window is kind of becoming colorless, but all the colors are projected in a kind of carpet of light. This is another picture of the same object in an exhibition later. And so because we failed and because there was so much work, I was very depressed, so I decided to write a book about the project. And nicely, the book became part of a collection of a museum in Paris, Musée des Arts Décoratifs. So that's the book. You already have seen a few pages of the book. Here are a few other ones. So that's the clock, or like kind of global representation of the project. And so I have had the opportunity to continue this project, but in a different fashion later. So I was a resident in the Belgian Academy in Rome in 2017, 2018. This is the building with my work on it. And this is another picture of the work that I ended up doing there. So I spent first 4 months there where I was developing a research around natural light and glass painting. The research actually changed a bit, but this doesn't matter. And during my residency, I spent a lot of time on Google patents, studying patents about glass painting, and I found out that there were many kind of forgotten technologies of painting on glass from the 1930s to the 1990s. And it is possible, in theory it was possible to paint directly on the glass and to have something that is weatherproof and resistant to fading, etc. So I was very excited and I started a research about that, and I came up with a technical solution to reproduce the property of this opalescent glass that I was showing before by just painting directly on the glass. And this required very fine particles of white pigment, exactly like in the Da Vinci codes from 500 years ago. So that's why I was so amazed. So these are some first tests. The first tests I was making were really about the interaction between the coating and light. You can see that the same thing can change quite a lot in appearance just because of the light. But these coatings were too thick and not very stable. And so I ended up doing these very fine coatings that reproduce actually the phenomena that were described by Da Vinci, where something colorless acts like a small atmosphere, and you see these white pigments appear completely yellow because they scatter blue light. So exactly in the same way as the Earth's atmosphere. So for example, this thing on the table, the same thing when you look through, you see the color is completely different. Yeah, these were tests. I did a lot of tests, and I ended up making a prototype that you will see later. I also continued the research that I made before for the church, which implied some kind of mathematics. I spent a lot of time on this, trying to figure how to generate pattern that I understand more, because sometimes you do something, it looks very nice, but you don't understand anything. So I coded my systems and I tried to understand how it works and how to make something interesting with it. And I ended up with this kind of patterns that look very much like some Islamic patterns or some Christian patterns, also from like the 12th century, for example, in Pisa. And I was searching for ways to simplify them, and also since it would be painted on the glass, I didn't have the same constraint as when you actually build the stained glass with lead lines and etc. So I was much more free in the possibility of drawing with these geometric patterns. And so then it was time to find money. So I was lucky enough to find a private sponsor, and also the Fédération Wallonie-Bruxelles, which is a Belgian state regional funding thing, accepted to give money for the project. And so with the money I could work on this project last summer, and in 1 month I have made a permanent installation in the building. And these are some videos where you will see how I apply this coating on the glass. This looks very garage, but it's actually quite nice chemistry. And you see when I apply the thing, this light is popping out instantly from the glass. And so what I'm basically doing there is that I'm scratching the maximum of pigments from the glass in order to have these very thin particles and produce this optical effect. Then the second step is to fix this. There's some kind of chemistry applied on the glass that makes it resistant to rain and to water in general. And then the last step is to rinse that with water, which is also an instant proof that it's water resistant. So these are some pictures of the result. It looks very clean and tidy, I would say. And this was a time-lapse video that I have made. And you will see that this work is kind of, so every element has a different relationship with the natural light. There's also a building behind which is black and white. And so depending on the moment of the day and the angle and the color of the light, you have a lot of different shades of this object that appear or disappear. So for example, just now the black line just appeared, but they can also disappear depending on the light. And those small squares can appear very bright, or they can vanish completely. So that was the teaser for the inauguration. A very short one. These are some other pictures to give you an idea of the scale of the work. It's about 22 meters long on 5 glass panels that were already there. And there's a last thing I wanted to talk about, because it's a project that I'm currently working on. I called this like a sky lamp, but I don't know, maybe it's a temporary name. And it's, so just to introduce another context, since it's been 1.5 or 2 years kind of that I'm developing my own use of LED technology for different projects, and one of these projects is a command by a Belgian collector. She wants a lamp for her house, and so I came up, because this is obviously something that is important for my work, so I came up with the idea of reproducing the color and the light from the sky within a lamp. And for this I use, I do my own LED tuning. So I don't know if you know, but most LEDs are blue LEDs with some powder on it that transforms the color blue into something else. And so I'm using these materials called phosphors. It's a lot of chemistry, if you want. And with the phosphors I can tune the color of the LEDs. And so these are some pictures of my studio while I was measuring the colors of the LED at night. You see that there are 2 different colors here which produce 2 different kinds of shadows. It also looks like the sky when it's about time to stop working and it's 8 a.m. I'm using some color science. I won't explain this to you, but you see that the products are coming from China. It's a whole constellation of things that converge in my studio. Science and chemistry. I measure the light produced by my custom LEDs with some scientific instruments. And this is a video that shows you like different samples of what I can do with these powders and these LEDs. And so these are actually samples from the lamp that I'm currently working on that you will see after. So there are different colored LEDs that I can change the color, I can control the color of the light. And then with this I'm going to reproduce the colors of the sky in the lamp. So you see, the first one was very orange. Now we are going more to the direction of kind of what's coming out from the lamp on the wall there, but it can go more to blue, etc. Yes, it's almost done. So this is a picture of the first prototype. So it's a big aluminum lamp, 3 meters long, and you see that on my ceiling it actually kind of looks like the sky. So this is an aluminum housing, and inside you have a lot of LEDs, and I can control the color of each of them by putting some chemical product that transforms the light on the top of it. And so this is the lamp which is open, and when you put a diffuser on it, it has this very smooth gradient that also looks like the sky. And thank you very much for your attention.